Okay, today we're talking about estimating proportions with confidence. So this is actually the difference in proportions. So this is the little twist, is we're doing the difference in proportions today. So conditions for differences are pretty similar. The data come from two independent random samples. So we basically have to check for random sample, random assignment, that kind of thing, for both of the groups, both of the proportions. The 10%, guess what? We have to test both of them for 10%, less than 10%. And then the large counts, we have to test, again, both. So you have to do that kind of 4 times. Successes, failures, etc. Okay, so let's look at a problem and start doing it, I guess, right? So Harris interactive survey, at least check the conditions here. Asked independent random samples of adults from the United States and Germany about the importance of brand names when buying clothes. Of the 2,309 U.S. adults surveyed, 26% said brand names were important, compared to 22% of the German adults who were surveyed. So we're studying the true proportion of all U.S. adults who think their brand names are important, or the true proportion of all German adults who think brand names are important when buying clothes. So Germans think differently than U.S. adults. Check if the conditions for calculating a confidence interval for those are met. So what are the conditions? So are they both from independent random samples? So are they random? So it says they were random samples of adults from both the United States and Germany. Check. Okay. The less than 10% condition. So there were 2,309 adults surveyed. Is that less than 10% of the U.S. adults? Yes. 1,058 German adults, less than 10% of all German adults? Yes, we got those. And then you need to get your calculator out and start, and you would write this on your paper as well, but you do NP, right? So for adults, for US, it'd be 2,309. For successes, it'd be times 0.26, I believe. And then 2,309 times point. You can either do 1 minus 0.26 or you can just do 0.74. So we have at least 10 of each of those. That's good. Let's check for the Germans. 1058 times 0.22 and 1058 times 1 minus 0.22, which is 0.78, I believe. Those are both more than 10. We had a big enough sample size, so you can be pretty sure you're going to be okay there. This is the way they phrase things. So random independent samples of U.S. adults. Less than 10% in both cases. Large counts, they showed their work. They said all those things are greater than or equal to 10. So we're good. Okay. By the way, this is just kind of building the formula we're going to use, but this is what's on the formula sheet. So this is actually kind of a generic for any interval. You take the statistic plus the critical value times the standard deviation. That's just kind of a generic that is on the formula sheet. Then you have to kind of look up what you're doing. In this case, we're doing confidence interval for P1 minus P2. So on the formula sheet, you kind of look that up and realize that the statistic is P hat 1 minus P hat 2. The standard deviation or standard error is square root of PQ over N plus PQ over N for each individual thing there. So that is on the formula sheet, but you kind of piece this together to get the actual formula, right? So technically, the formula for standard error is when you use the P hats and Q hats instead of the P's and Q's there. That's the difference. It's called standard error. That's what's in the formula. Okay, so this is the formula that you piece together, so to speak. So you use the generic formula, you kind of look up in the formula box what the difference of proportions formulas are, and you can piece this together, basically. And this is our formula we're going to use. So we're going to plug in to this formula. So far, we focus on doing inference use data by random sampling. I think every example so far has been random sampling, essentially. In proportion from a randomized comparative experiment. So I kind of like seeing a slightly different example. This is definitely outside the norm. We're doing a lot of random sampling for these types of things, but you can do a randomized comparative experiment. They could throw one of these guys in there. So there's going to be a couple nuances, especially with the conditions that you'll notice. Things will be slightly different for this one, and that's okay. Just to, got to roll with the differences here and see what's happening. So patients, it looks like he's in pain. Patients with lower back pain are often given this kind of drugs like those things to ease their pain. Researchers wonder if taking the Valium along with naproxen would affect pain relief. So maybe the two of them don't mix well, or maybe they do. To find out, they recruited 112 patients with severe lower back pain and randomly assigned them to one of two treatment groups, naproxen and Valium, or naproxen and placebo. So that will kind of tell us hopefully naproxen is effective. Maybe with the Valium it's more effective, and so we can kind of compare the groups. After 1 week, 39 of the 57 subjects who took naproxen and Valium reported reduced lower back pain, compared with 43 of the 55 in just the only naproxen group in the placebo. So constructed and interpreted a 99% confidence interval for the difference in proportions of patients like those who reported lower back pain. So I think the conditions will be a little different here. So the first condition that's different is random. We're used to having random sample. Well, there's no random sample. We're not taking a random sample. This is an experiment. And so what you want in an experiment is random assignment. So we do kind of generically call that random, because if you're doing an experiment, it would be called random sampling. And we do have that. It says that they randomly sampled somewhere in there. Researchers were undertaking and assign them, random assignment. So it says with lower back pain and randomly assign them to one of two treatment groups. So we have random assignment, and so you would mention that in your condition there as your first condition. Second one is less than 10%. That's when you're sampling without replacement. This is not really, sampling without replacement. We just have a group, that we're studying. So it's an experimental group that's been chosen. They probably volunteered. They might be getting paid. So it's a little different situation. I don't think, let's see what they say, but I don't think you have to check the less than 10% condition in this case because it's an experiment. Let's see what they say on that one. We'll get to that in a minute. And then the NP and NQ, I think, would still apply. Again, I'm just kind of going to my gut here. Let's see what happens. So NP would be, let's see. So P hat for the first group would be 39 divided by 57. That's your P. So N would be 112 times that. And then 112 times 1 minus that. Those are both at least 10. That's good. Let's do the other one. So the other one was 43 out of 55. These are a little smaller, so you got to be careful, make sure they work. 112, I think it was the same. 112 times this guy. And P, that's number of successes. 112 times 1 minus that guy. That's number of failures. Okay, they all pass at least 10. Let's see what they said. This will be interesting. Okay, so they said state, I forgot the first step. I was already at the conditions. So state, you've got to talk about the parameter and the confidence level. So 99% confidence level. The parameter we're studying is the, let's go back to it. So this is the, so the proportion, make sure you use P and not P hat when you scribe these. So P1 would be the true proportion of patients who took, who had reduced back pain, who took naproxen and Valium. Whereas P2, again, not P hat, but P2 would be the true proportion of patients who had reduced back pain who took naproxen and the placebo. So something like that. Let's see what they said. So the true proportion of patients who reported reduced lower back pain. Good. Notice they put the order, and that, again, they're using P1 and P2, not P hat. So we're describing the population parameters here. So We are not going to use the hats there. These are going to be the P's in that case. That's what I think it says. Use P, not P hat, when you're describing the parameter of the population here. So we checked the conditions. Those were the conditions we checked. I think we already did that. So do. So let's go back to the problem. And so I would recommend doing this first part like I do some in your calculator here, but actually kind of plugging in the numbers for this one. So I think the first one was what, 39 divided by 57. And the second one is 43 divided by 55. So those are your two, P hats there. So you would start by writing out, P hat 1 minus P hat 2, so 0.68 minus 0.78 plus or minus. So this would be like negative 0.1, somewhere in that neighborhood. The critical value, how do we find that for the, this is 99% confidence. We don't really have that memorized probably. So 99% is in the middle, which means 0.5% is to the left and 0.5% is to the right. So your calculator, when you do inverse norm to figure out that Z critical value. So menu 653 is inverse norm. 0.995 is 2.57. So plus or minus 2.57 times square root of P hat Q hat, so 0.68 times Q hat, which would be 0.32, all over, I think that was 57, plus, I'm running out of room there, but it'd be 78 times 0.22, all over, I think that was 55. So that's all underneath the radical there. Show that work there by hand, and then I would, if I were you at that point, I would get your calculator out and go to menu 666, 2 prop Z interval. This is the name of this test. Really nice. It's already laid out for you. 39, 57. Notice I put P1 first because whatever one you put first, it's going to subtract. So I put that one first, so that's my P1. X2 is 43 divided by 55, and 0.99 was the confidence level. So now I have all I need to do. So for your next step, over here, you can write the ending from the calculator talk here. So negative 0.311. And that way, if you don't have any rounding errors there, if you did that, I like putting the P hat or negative 0.097. I think at negative 0.1, I'd round it a little bit, plus or minus 0.213 or 214. So, and then show that work that you had for the first step already. You already did that. So we have our nice our work shown there. That's the do. Perfect. That's exactly what we showed. We did the second two parts with our calculator. The first part, we just plugged in the numbers we knew. So the last step is to make a conclusion. Just see how it rolls with a difference in proportion, just a slight difference. Starts out the same. We're 99% confident the interval from blank to blank, from negative 0.312 to 0.116, captures the true difference in the proportions of patients like those who would have reported reduced pain after taking the approximate Valium versus after taking the approximate placebo. So it's not just the true proportion, but the true difference in proportions. That's the biggest difference in the interpretation there that you have. I think this is interesting. So this is a very common follow-up question. Based on the confidence interval from part A, what conclusions can you make about taking Valium with approximate effects pain relief? So here was our interval from that to that. So let's pretend that both methods are exactly the same. There's no difference. We expect the difference in the proportions to be 0 then. Is 0 part of these plausible values? Well, this is negative, this is positive. So zero's in between them, so yes it is, which if zero is a plausible value, we don't have any evidence to say that, anything's happening here. So let's see what they said. Because zero is not one of the plausible values for the difference in the proportions, we don't have convincing evidence. So valuing along with an approximate affects pain relief. It's not the best method necessarily. We did that. Okay, last step. This is one that I have a worksheet for you that you can write out your work really closely and nicely there if you want. So this is about President Trump's approval rating from when the time he took office to the 100th day in office. And they took a Gallup poll, 1,500 random affected U.S. adults, and he had a 45% approval rating at the start. And after 100 days, he had a 38% approval rating. Construct and interpret a 95% confidence interval. Okay. So we want to start with, the parameter and the confidence level. Confidence level is 95%. Parameter we're studying would be P1. I would call it P1. Represents the first day in office. Is the true proportion of folks who approved President Trump at that time in the United States. And P sub 100 is the true proportion of people who approved President Trump after the 100 days, right? So you need to put an order to this. So in this case, like P100 minus P1, you could choose a different order. The other class asked that. I thought that was an interesting question. Your results may end up being positive or instead of negative or vice versa, but you pretty much get the same results. And it's okay. Unless they specify in the question the order, you're actually allowed to do it either way. But you want to do the difference. We're comparing the two. That's how we compare two proportions. We subtract them. If it's positive, it might tell us one thing, and negative might tell us another. So you check the conditions. So again, the conditions are, and you also name the test as 2 samples the interval. So independent random samples. So these are random samples for both the U.S. On the first day and on the 100th day. Check the conditions less than 10% for both groups of adults here on the first day and the 100th day. Large counts, do NP for each one of them. You got it there. Have to be at least 10. Plug in the numbers. Look at the last two, I would definitely do for the calculator. So I would have hit menu 666. It says that. So in this case, like just so you know how you get that. So you almost have to start by doing the, what's 45% of 1,500? And what's 0.38% or 38% of 1,500? So 675 and 570. Just need to remember that. 675. So I'm going to hit menu 666, which is 2 prop z interval. You get 675 out of 1,500. And then you get 570 out of 1,500. And I believe it was the 95th. Yeah, that sounds right. Okay. So it gives you the lower bound. And again, depends which one you plugged in first as to whether this is positive or negative. So I plugged in opposite of the way they did. So I did the first day in office, and then I did the 100th day. They did the 100th day and then the first day. So ours are opposite sign-wise, basically. Same answer. Not worried about which way you do it in that one. Conclude we're 95% confident the interval from blank to blank captures the true proportion or the true difference in proportions of those who approved Trump's job on the first and last day. Based on the confidence interval, remember they're both positive there or both negative, depending on which way you did it, is 0 in the interval. It's not. Therefore, we have convincing evidence that his approval rating changed. In fact, it went down around 3 to 10% when you look at the percentages there for the lower and upper bounds. So that's it for today.